David Chandler. I work with Digital Insight. We were recently acquired by Intuit. We run the internet banking presence for 1,700 banks and financial institutions. So if you use a credit union or a small regional bank, there's a good chance that you're using our software. And I'll be happy to take your comments about that offline. But the only reason that I sleep at night is because I'm not in the security group per se, I'm in the architecture group. My job is to try and get the security baked in from the start when we write new applications. CGI applications, and we recently began moving toward Java. So I spent the last couple of years working with JSF and figuring out how to secure JSF against the OWASP top 10 for starters. So that's what I'm going to talk about today. JSF, is the J2EE standard web tier framework now. It's model view controller based, it's tool friendly, and the question everybody wants to know is, JSF application. Wow, okay. How many people have ever seen JSF code? Okay, a few more. So that's fine. I'm going to do a little review as we get started of some JSF core principles, and hopefully that'll help. So this is my notion of a framework security continuum here. At the very bottom, you have those frameworks which make it impossible to create a secure app. Would be the holy grail. It would make it impossible to write an insecure app, right? I don't believe those exist. So our jobs are somewhere here in the middle. What I'm looking for, my goal in starting this process 2 years ago was to find something that would let developers do all the right stuff, but would make it easy to use code scanning tools and limited inspection to find holes, rather than. So if there's things that we can do by a more automated fashion, then that's ideal. So what we want to do today is address any framework and implementation vulnerabilities. We want to learn to lock the front door and the back door. The front door meaning, we require authentication, and back door being hacking. Then we talk about ways that we can make it easier to inspect our code for vulnerabilities. Which was updated this year because the number one thing in the 2004 version is unvalidated input, and that's where, as we know, a great number of problems begin. So it fits my presentation better. Also because I wrote the presentation last year and haven't updated it yet. Okay, so JSF is a spec, not an implementation. There are a couple of popular implementations, the Suns being the two most common. It fits in the frameworks universe and it's MVC, builds on the struts controller and form bean concepts, and it brought in from Tapestry the notion of components. And the component-oriented nature of JSF is one of the things that gives us a lot of power for security. There's basically three moving parts. We have view templates, which by default are JSPs, but 3 years ago, a guy named Hans Bergsten, who worked on JSF, wrote an article called Improve JSF by Dumping JSP, and that article pointed out a lot of problems, performance and interoperability-wise, and so a guy came along and Jacob Hookman created facelets. And facelets let you extract your view templates in XHTML files rather than in JSP. There's some security, definitely some developer convenience benefits associated with that. And you have navigation rules. And that's about it. JSF really doesn't have a lot of moving parts. So we're going to talk about the various concepts here, beginning with components. Now, a component looks a lot like a JSP tag. An example would be h:\text input, which would render as a input type equals text in HTML. The idea was to separate business logic from presentation to a large degree. So in JSF, you have a data table component, for example, that accepts as one of its attributes, the value attribute, a Java collection. And the data table attribute will iterate over the collection and render all the rows in a table format. This is different than how you usually do things if you're coming from like a struts or just straight JSP world, where you actually have to put the iterator into view yourself. You're kind of mixing the business logic with the actual presentation. JSF has tried to get away from that as much as possible and go more declarative in its syntax, which assists with code inspection quite a bit, actually. So the most common way to build up your hierarchy of components on the page is via the templates, either JSP or faceless. But you can, if you want, and drop them into your view that way. There are two groups. There's the faces core components, like F:\view and load bundle, and then there's all your HTML wrapper components. So HTML select many, we actually need select many checkbox, or select many radio, or select many list after their renders. Component render is actually, most components delegate their actual writing out of the HTML to a renderer, so it's a separate class. And what this allows you to do is to have the same component, but actually multiple render kits or multiple renderers for a component. So you can conceivably render to HTML, WML, Flash. So far, though, it's all theoretical. Okay, manage beans. These are just POJOs. I use them like view controllers typically, so they link your view to your model. Sorry, view to your model. So they're going to do things like providing event handlers. When you click on a save button, they call some method of manage. They call a method on the manage bean to populate your select list. Okay. They can be in any of the standard web scopes, and these are managed by the framework. So when you instantiate a manage bean in JSF, it's never you doing it directly, it's always the framework doing it. And the way that works is if it's walking down a view and it sees a reference to a manage bean.property, then it will call up faces config and say, hey, do I have this bean yet? If it doesn't have it, then it constructs it, puts it in the scope where you specified it, and then in the future it returns it from that scope. Challenges in JSF that frameworks like Shell and some other things have addressed. It takes a little bit getting used to that you're not the one instantiating all these needs. But once you get used to it, it's very convenient. Okay, value binding might be best shown with an example first. This highlighted part is an example of a value binding. This is an H:\. Browser. And we're binding to something called logger.fi level. Well, logger is the name of a managed bean that would be defined in your faces config file, just like, well, not like that one, because this one isn't called logger, but it's the same thing. You have a managed bean declaration with the scope and a class name. And then it's looking at some property fi level. So JSF uses the Java beans naming convention, so it knows to call the methods get fi level and set fi level to get that property. So this is a value binding. This concept is fundamental to JSF. It's how everything works. It's how you get data to and from your views. Now notice, just a preview here, this syntax is something I really kind of like. The way it populates your list is with this F:\select items. This is standard with all the controls, select one radio, select one checkbox, select one menu, etc. They all use select items to populate the list. So there's a certain symmetry that's in the language that's helpful when you're first learning. Okay, now we have the notion of converters. This fi level up here, you notice, go back one more page, that the fi level is not a string. It's actually an object of type enum log level. So how does JSF know to convert from an enum log level object to a string that the UI can use? And the answer is we define a converter. Now JSF provides standard converters for integers, all the big B wrapper types, big B Boolean, things like that. But they're bidirectional. So again, in this value binding example, when we're rendering the view, JSF is going to call the getFI level method. Boy, I keep doing that. This is just a good page, and I really want to be on it. It's going to call the getFI level method. When input comes back in on the subsequent form post, then it's going to call the setFI level method. We'll go through all that exactly how it works. But it's important to understand that converters are bidirectional. So they have two methods, getAsObject and getAsString. And getAsObject is what's used for the strings coming in from the UI and vice versa. Then there's also validators that actually validate objects, not strings. So all your format checking kind of stuff typically gets done in a converter. So if let's say you have a field that binds to an integer property, so JSF's by default its integer converter will come into play, and you as the user type in ABC123. The converter is what's actually going to detect that, hey, I can't make that an integer because you've got letters in it. Then JSF supplies standard converters for date, time, and numbers. We'll look at those a bit later. And then the real power is that you can write custom converters for your own rich types or to get special behavior out of the default types. So in fact, in that previous example, I've defined a custom converter, and we'll show how that happens momentarily. So this is a pretty simple interface. If you want to implement your own converters, you just have getAsObject, getAsString, and then a validator is also very simple despite all the junk because it's compressed into a small space. There's really only one method called validate, and it takes. So these get registered in basis config, which is the central configuration file for all things JSF. And there are several different ways to register, and we'll talk about that. This converter for class is the most interesting from a security point of view. That says that any object that it finds that's bound in a value binding that is of value type safe enum is going to value type safe enum converter to get a string representation of that, and then coming the other way to get an object representation of that. So what this means is that, let's say you have security rules around an account number and what an account number cannot contain. Then you can actually make your objects of type account number register a converter for that account number type, and the converter will automatically get invoked then no matter where in the UI you can bind it to any control, and that converter is going to get used. Okay, the controller, I'm not going to talk about that right now because it's not as relevant. JSF event handling, this is what the syntax looks like if you have a command button, submit form, that's what it looks like. Applicational command button, and then an action attribute that references a method on a managed bean. That's all we need of that for right now. Alright, so the JSF request lifecycle. You know that all web applications do the same things, right? And the request lifecycle just formalizes that. It says these 5 or 6 things are going to happen with every single request. Well, the first one is kind of interesting and not common to a lot of frameworks, the restore view. This actually, the JSF, all pages post back to themselves, but not in the same way that a JSP does or whatever. A request comes in, if you are on editcustomer.jsf, then that request goes back to editcustomer.jsf. So the first thing that the engine does is to restore the view. It reads the view back into memory to say, hey, what was I looking at when we were on that page? Then it applies the request values, which all of these things just work that's in the view. So for each input component that it finds, it pulls in a value and it says, this is the value for that component. And the next step is to process validations. So here, we're going to take all those applied values, we're going to convert the strings to objects, and then validate the objects. And then, once validation is passed, and only validation is passed, as we'll see in a minute, then we're going to call the setters on the managed beans to actually update our model. We're not talking persistence here, but just our managed bean model. After all that's done, so that saves all the form into your Java objects, basically. And then when that's done, then we call the application method, if there was one, like save data. And finally, we render a response. So that's the basic life cycle. It happens on every single request. It starts, goes through the life cycle. All your form variables automatically get saved to your managed beans through this process. And validation always happens along the way. So we're going to talk about some more details of that shortly. And extension points I'm going to skip. We'll introduce them as we need them. So last little piece here, JSF configuration. You do that through facesconfig.xml. It contains your navigation rules as well as any extension points that you add. And you can break it up into multiple. Also read faces config snippets out of the jar in the .inf directory. And that's real handy because if you write a custom component, there's a little snippet in faces config that you need that registers that component. So you can package your component as a jar, put your little faces config snippet with it, and it all works. You can just drop in the jar and you don't have to do any additional configuration. All right, so here we are with let's take a look at each one of these in order, and I'll warn you, the first one takes about 20 minutes, but because unvalidated input is so important, the rest go really fast after that. All right, what are we talking about here? Parameter tampering, required fields, length, data type, allowed values, etc. So validation in JSF is part of the request lifecycle. There was that step process validations, which means that the developers of JSF were considerably security conscious, at least enough to know that, hey, we need to make validation a first-class citizen. So this is what happens. If validation fails for any component, it will throw a converter or validator exception. It will add a message to the message queue that you can display on your view. So it looks like this. Validation fails, then we're skipping over update model and invoke application and going directly to render response so we can display the error message. Now, what did we not do? We did not update the model because our data were invalid. And we did not actually do anything with any data that we would have updated because, again, the data was invalid. Unvalidated data to make it into your actual model. And JSF enforces that for you. The user remains on the current view, no action methods get called, and messages get tagged with the component ID as well, so you can pull those out. If you want to show an error message for a given component, you can show it right next to the component, which makes for a little nicer UI. So all this is true unless you hack it. It doesn't, and this is where it's not that holy grail framework, right? It's you still have to do the right stuff. If you want to put in a hook called immediate equals true and something called a value change listener on your component, then that will let you call a method in your managed bean that will let you directly access the HTTP servlet request if you want. And you can read unsafe data from the HTTP servlet request and you can do with it whatever you want from there. But JSF will never do that to you. If you're using the framework as it was designed to be used, it will never update the model with invalid data. Now, of course, your validation rules may not be very good as well. All right. So let's look at the next, the first area of unvalidated input, parameter tampering. Here we're talking about hidden fields, playing with multiple choice boxes, and required fields. Did you say hidden fields? No one can tamper with hidden fields. No, of course we know that's not true. You have to validate them just like any other field. There's nothing that JSF can do about that or any other framework for that matter. Now, with the multiple choice selections, JSF gives you a lot of help. Because what it will do is when a value comes in for a selection, it will go back and call the method that was used. Comes back was in that original value set. So that way you always know that it prevents parameter tampering. I mean, yes?
In the presentation, is it actually substituting those raw values for something else, or is it taking a raw value and throwing it in there? Like a GUID or something like that? Is it doing substitution? Or?
JSF itself doesn't do any substitution. You to do a substitution.
Okay.
But no, it will take whatever you give it. Yeah.
Thanks.
I've actually got a slide on that one too. So JSF prevents against parameter tampering. This is one of the things you can do because of the component model. Now be advised, because it does call the method that was used to populate the list, if you're doing, let's say that method is just making a call directly to the database to get its values, that means for every request response on a given page, you're going to see that query executed twice. Once when you render the page, and once when the subsequent request comes back in. So if you want to, say, cache the data so that it doesn't, A, you're not hitting the database as much, and B, the values are stable between where you presented the data and where the value comes back in, then you can do that, but JSF doesn't do it for you. The easiest way would just be to cache the result rather than going to the database again. All right, required fields now. JSF helps with these because there is a required attribute that you can put on any input control, and you can set it true, false, or some expression. If the required field is empty on the subsequent request, then JSF will fail validation. It will throw a validation exception, say required field, and do the same things we talked about before. You can change the default message in the properties file. That's standard IETN thing. There's a hook in cases config to substitute your own properties file with your own messages. And if you really, well, let me talk about the required attribute itself again. This is the component is required, and the field comes back in. The server remembers that because it's restored to view as the first step, right? So it's not possible to hack around that. The server knows that it's required, and it's kind of neat that it's right there in the field. So, and this is the same with converters and validators. I didn't talk about one of the ways that you hook those up, but common way you would have an H input text, no closing tag here. Inside there you might have F:validate length, for example, and then you're closing H input text. So as a security reviewer, you're looking at the code, you see all the rules associated with a given field right there in the field, which makes it very easy to verify that, yeah, I am protecting properly what I'm doing here. Now, I said that, it restores on the server, whatever, but here's an area where Apache MyFaces at least, and I think JSFRI as well, weren't as security conscious as they should be. I said if the required field is empty, JSF will fail validation, because normally for a text input box, you'll get the parameter name equals in the URL, and then it'll just be blank, so then you'll see ampersand, next field equals, whatever. But suppose you use a man-in-the-middle tool like Peros or WebScarab to actually remove the field name altogether from your request. Well, it turns out, due to some unclarity in the spec and some unclarity in the part of people who implement it, that you can actually sneak that past JSF and it won't fail validation. I submitted this as a bug to Apache, and when I showed it to one of the lead Apache developers, I pulled up Peros and started editing the request, and he goes, "What is that? How are you doing that?" And I'm like, "Don't tell me this." The middle tool is. So, anyhow, it was fun. But this is one of the only things I found that I think is an actual flaw in the implementation. And the good news is, it's in the component itself and the shared library that patches it is for the components. So it's pretty easy to change if you want to do it. I've got a patch up there which they don't like, and it's a way longer discussion than I can have now. Okay, so let's talk about validating standard validation rules now. So JSF provides 3 standard converters. You have validate length, which is just length of string, and then double range, long range for numbers. And that's it for standard validators. There isn't a whole lot more than that if you're using standard anyway. Now thankfully, the Tomahawk project has added some more commonly useful validators as well, including email, regex, credit card. It just does a lot of 10 algorithm. So there's a good library of things out there. The max length note does not actually affect validation. Validate length affects the JSF validation, but if you just put a max length attribute on your tag, so there's also built-in converters for all your wrapper types, and then for date, time, and number. The date time one is really nice because if you just go in and change your browser locale, and then JSF reads that as part of the process, and since the standard date time converter is getting invoked, it'll automatically change your date to whatever locale. It's all built in. It's very nice. Obviously, if you have more interesting validation rules than what you want to put into regex, or if you want to centralize them somehow, then you need to create your own converters and validators, which is very easy to do. It's just a Java class that implements that interface. So validators can be invoked in one of 3 ways. You can write your own component, which is usually more work than you want to do for just validation. You can create a validator tag, like my custom validator, that you can insert between any opening and closing tags for an input control. Or you can actually reference the validator ID right in the input control itself using this validator attribute. And even if you really don't want to do this validator anywhere but this one place, one time, you can actually have it call the validator method right from your managed V, which is the easiest way, but the less. Okay, converters, also very simple. They give you this one additional option of registering a converter by class in cases config. And that's where I'm saying that anything that implements this interface or extends this base class is going to get converted using my custom converter. So one thing you could do with that would be to say create a custom converter for all strings in your application. So you can create a base class string alphanumeric, for example, which is going to do validation for the character set. And then you might extend that with a class called usercode that also specifies a length of 14. So anywhere in your application you're using usercode now, instead of just making it a string, you make it an actual usercode type. And then there's a converter registered once for all string ANs in faces config. And so now any class that's bound to any control that happens to extend from string AN is going to get validated with your rules. So this actually allows you to take your validation rules and bring them out of the view template and move them back into model code. It also makes sure that you're writing more type-safe code, because now it's actually impossible for me to even construct an invalid instance of a user code object. So this is, for model-driven people, it's a really nice technique. At one time, I was very excited about it. I think it's still a nice idea. However, it actually makes your security review problem harder, because now you have to go through your view template and you no longer see the little f:"validate tag right there with the rule in it, because it's implicitly getting pulled in by the type of variable that's bound in your value binding. So it makes it a little trickier, which means that you need an even better trick to make sure that all the validation is still done. We're going to talk about that in just a second. So the strengths of JSF validation, they're all declarative, which makes it easy to spot. For example, in a view template, you know, one of the problems when you have multiple exit paths from a page, you might have 3. So where do you put your validation rules? Well, in a typical scripting type model, you have to put them in each of the 3 places where your application goes. Right? JSF request lifecycle and component model solves that problem for you. It always restores the view and does validation based on the page you were on, not the page you're going to. Which really, if you think about it, makes a lot of sense. So the model never gets updated unless your validations pass, and then class thing to do highly model-driven validation. Now, so here's my hack, my way that if you're doing this model-driven validation and registering a converter for a class, you want to know for certain that every field has been validated properly with a safe validator. And you're too lazy to read all 2,000 files of JSF view templates, so what do? Well, what you could do is to create your own that would keep track of when they ran. So they could just, let's say they could write the component ID that they validated into some request object. And then you would have a phase listener, which is a JSF thing that runs before or after each phase in the lifecycle. And the phase listener could run after the validation phase and just make sure that every component has been validated by one of your safe validators. A full regression cycle, for example, and anytime there's an unvalidated component on a page, it's going to throw an error and you're going to write up a bug. So whether you would use it in production or not is up to you and your determination of impact on performance. But I would definitely drive through my entire app with something like this turned on so that I know for sure that I've caught every single field. Nice thing to do. So it dramatically reduces your code inspection burden. Okay, one question that commonly gets asked is, well, how do I validate related fields together? These are almost always business rules, like start date less than end date, and not format things specifically. So the best place to do them is actually in your being action method right before you execute the method. You can still do all the same things that you would do if JSF validation were doing it, but it's just a lot easier because once format validation has run and passed for all the components, then you actually have values, objects in your managed bean to work with. Before that happens, you would actually have to call into the component tree and get the raw string, convert it, and all that, which is a pain. So, but if you really insist that you have to do cross-field validation in the validation lifecycle, you can use this little dummy technique. Put in a dummy hidden field, have it call a validator method, and that validator method would go and walk the component tree, find the strings, and look at them. Yep. All right. Now, JSF and Ajax. Ajax obviously is becoming very popular. There's a lot of issues security-wise with it. Frameworks that have been created, iSpaces and Ajax for JSF, that give you a lot of help here because they retain the full JSF lifecycle and they retain all the characteristics of the component model. So what this means is if you do a partial page submit where you're just submitting values from one control, let's say, and a partial page update coming back, it's actually still running the whole request lifecycle on the back end. And that being sent for update, it's running validation on it like it normally would. So, and you don't have to do anything special for that to happen. All you have to do is use the wrapper tags that these frameworks provide that mark this area of the page as being the one I want to update automatically. And you get all the benefits of validation for free. So I'm excited about this stuff because this makes it really easy to write good Ajax apps with properly validated. Personally, so I expect there may be, because they're relatively new, some other security vulnerabilities in the frameworks, but JSF validation will not be one of them. Oh, and And neither one of these uses JSON or any of that direct data stuff to JavaScript, so you don't have to worry about that.
What does that mean specifically? Are you just passing it as XML or?
Yeah, it's actually doing a normal, well, I don't know.
Okay.
Yeah. I know that the way it's doing the updates when they come back is it's just doing like an intertext write on the page, so it's actually getting an HTML snippet that's being written back, just like you normally would have. So as opposed to sending back data and then writing HTML from the data, which
It's
is what
sending the raw HTML.
that you're interested in.
Do you know if it's using document.write or is it actually using creating the? Because
No, it actually creates the HTML on the server, and then
so it seems like it would have to use. Well, okay, so if you're using inner HTML, I guess that would work, but
yeah, and this is where
it's not good.
I'm making stuff up, right?
All right.
I don't know for sure because I haven't looked at it that closely. I just know it's not using JSON. Okay, so forced browsing. Now this is another interesting one. And also I'm going to include the CSRF attacks in here as well. JSF prevents forced actions in the sense of you can't fake it out by clicking a button that's not already on the page, because in that restore view phase it's bringing back into its mind what was on the page, including all the buttons. So you can't make it execute some action that's not even available on the page. That's a good thing. But you could still go to another view out of sequence and cause some action to happen there. So how do you prevent that? The same technique that Eric talked about yesterday with the CSRF guard is what you can do in JSF. There's a central place called getActionURL and something called the view handler that all forms and links that are created with JSF tags go to this one method to get the URL that they're supposed to write out. So when you do a form tag in JSF, it's just h:form close tag. That's it. There's no action. That's all you write, because the framework supplies that URL automatically. So what you need to do is just add a token to the URL, which is a hash of the URL itself with some key that you have. Servlet filter, like CSRF guard has, that looks at the incoming request, looks at that token on the URL and says, does the hash compute? And if it doesn't, then you immediately reject the request. Now this is really cool because as a developer, you're writing your view templates, you don't have to worry about this. You just use h:form and h:command link, just like you always do. And you can shut down a whole bunch of classes of attacks using this kind of approach. So this is one thing I'm really excited about with JSF. And the example here says phase listener, but I thought about it after Eric's presentation. It'd actually be a little bit better performance-wise if you did it in a servlet filter, because then you don't do any JSF processing. You shut it down right at the beginning of the request. See if I can contribute that somehow. Okay, number 2. Now remember, that was the longest part, so we're going to make it to the end. Forced browsing past access control checks and client-side caching. A couple of quick things here. JSF doesn't provide an authentication framework per se, but the standard ones work because it's a servlet. So servlet filter is what most people use. If you're not authenticated, if you don't have a session, then you get popped out to the login page. Within a view, there's some interesting things. Each component has a rendered attribute. So you can say rendered equals and point it to some method on a bean that will return a Boolean. That'll determine whether that component should show up or not. So you could do, user has permission X, implement a manage bean that will provide that kind of control. And so you can turn on and off things in your, if the user doesn't have permission to update, employee salary, then you just don't put that link on the page. Now, because it's JSF, and if you're using the force browsing preventer like we talked about, if you don't put the link on the page, then there's no way they can force browse to it. So you actually only have to check when you write things to the view and not when things come back as well. You are checking it when it's coming back, you're just checking it implicitly based on other factors. So it takes a little getting used to. It's like, oh boy, no, that can't be right. I always have to check the action coming in. You are. It's just not, you don't have to do it as a developer anymore. Okay. And you can also write a custom component to lock down particular pages if you wanted. Controlling access to actions. One thing I haven't talked about yet is the action list. And it will intercept all incoming events like button clicks and link clicks. So it's conceivable that you could annotate the methods of your managed bean with some kind of thing like, @user role equals admin, and have this action listener envel look at the annotations on the managed bean that's the target and make sure that the user is in the proper role to do this action. Something like that as part of this cracked framework, if I'm not mistaken. Okay, so you're at the public library using your terminal. You log out. Somebody walks up from OWASP, hits the back button 3 times, and sees the money transferred. So what do you do about that? You have to write out the cache headers. Standard solution with every web application. JSF, it's just easy to do. With a phase listener, I think you could probably do it with a servlet filter also. That would write the standard cache control headers to the response. It's going to happen automatically with every request, and well-behaved browsers won't cache the data on the client side. Okay, broken authentication. This is not JSF specific. It does help you a little bit that all forms are always posted, which is one of the standard guidelines. You shouldn't be doing login by GET request because it gets stored in proxies. So the force browsing preventer we talked about can actually help you, /CSRF, whatever, can help you with this because requests would not contain the valid hash. So when you get the email spam, that happens to know about the URL structure of your bank's website, it doesn't know about that session token that you have, and it doesn't certainly know how to compute the hash. Now, as far as input filtering, we talked about that. You use converters and validators to do that. And then output filtering, JSF standard output tag, the H output text and H output format will automatically strip the dangerous characters. Now, I haven't seen Arsenic's cheat sheet yet, and I need to check it out because I suspect that JSF does not automatically pull out everything that's on its cheat sheet. But it does pull out these 4 characters, which look pretty dangerous to me.
Is it sensitive to encoding schemes? I mean, can you explicitly specify what encoding scheme of string data you're dealing with, or?
I'm not sure.
Okay.
I think that happens earlier in the request. So if it saw a view, if the request was for a particular encoding scheme, I would hope that that's what it would use to do this, but I don't know. Again, the whole canonical representation. So this is where a smart person, I can tell you the line of code you need to look at. Escape equals false, though, is an attribute you can add to your tag, which will disable this behavior. So that's an easy thing to look for if you're a security guy. You go through and see escape equals false and go, oh, okay, what's going on here? Because now we're vulnerable to cross-site scripting. Now, all other HTML components are safely rendered. They do the same kind of thing, like the select name list, whatever. But if you happen to be using H output text within a JavaScript block, I don't know why you would do that, but if you were, then there are other characters that can cause problems because of JavaScript escaping, so just be aware of that. All right, so these are the basic things you have to look for. I am starting to get really short on time, so we're going to zoom through the last 5 slides. But might be a problem with your database, for example. So the main thing is you just validate length all the time, and there's no need to have people sending million character fields. SQL injection, not a JSF issue because it doesn't, it's a web tier thing only. It doesn't care how you get to the database. So you parameterize your queries. JSF can be things like this. A lot of times you'll see the URL contain an ID with your real account ID in the database, for example, which is information leakage. So what JSF will do is it's got a couple of classes you can use in your managed means that will actually wrap the rows in a data table and just create a simple index, 1, 2, 3, 4, 5, 6, 7. So you're not giving away your real IDs. And then on the subsequent request, you call a method called get. So that's a helpful thing. It'd be nice if it would also do like hashing based on some value. It's kind of hard to write, but I've looked at it. IDs and options, I'm going to skip. Okay, improper error handling. Facelets, if you use that, which I do recommend, has these beautiful error number in your view file where the error occurs. And you can get a stack trace and lots of other interesting stuff. But you don't want this in production, obviously. It's too much information. So you need to set facelets.development to false. And then they'll bubble up through your normal web XML error page. Okay, insecure storage, we're going to come back to in just a second. Denial of service. Okay, I've been waiting for years to ask this question. Does anybody know what the name of ping-L65510 was back in 1995?
Ping of death?
You got it. First person that's ever got it right in this presentation. Yeah, so I'm working as a Unix admin. I see stuff on ping of death. I'm like, oh, that looks really interesting. Let me try this. So I picked a victim server in our server room that we weren't using for my Windows box, ping-L65510, my server name, and I go into the other room and it says operating system halted. I'm like, unbelievable. That was such a great hack for denial of service. But it's all been patched for years. So as far as I know, there's nothing like that in JSF that you can ping of death it. But obviously, if you overload any web app with a lot of requests, you're gonna have problems. So that forced browsing preventer thing that adds the token to the URL can give you a lot of help there because you can cause bogus requests to get rejected early. And finally, insecure configuration management. Up to this point, when I've talked about the view being restored at the beginning of the lifecycle, I've said it's on the server. Well, JSF actually gives you two options. It can restore from the server, or it can actually base64 encode it and send it to the client. Well, base64 encoding is not encryption. It's easy to decode. And there are potentially interesting things that you could do. I haven't actually verified that you really can do these things, but there are things I would be worried about as a JSF person. Like change expressions that populate fields, perhaps replace some of the validators or specify different validation rules, things like that. They can actually, if somebody was able to decode that base64 blob, which you can do trivially, they could potentially mess with your view. And you don't really want that. So the thing you have to do is to use encryption. Unfortunately, Apache MyFaces has a way to specify an encryption key and algorithm in your faces config. So if you want to use client-side, what do you call it? Client-side view saving or whatever, then this is the thing you need to do. Now, client-side view saving, nobody does this really for performance reasons. But it does solve one problem very nicely, which is the back button. When you have in multiple windows also, if you want to keep track of your page flow with 3 or 4 windows going at the same time, that gets messy when you're using server-side state saving. So it's nice if you can use client-side for that. Now when I say state saving, I'm not talking about your HTTP session, right? Your managed beans that are that stuff never goes to the client. I'm talking about actual properties of the view itself that get restored coming back. So, and finally, finally, on the subject of configuration management, if you're using Facelets, you need to lock down the .xhtml extension that Facelets uses by default. Otherwise, Wiley user simply goes to your URL, types in, my review template. So that's not an issue with JSP because it would try and run the JSP processor. But with Facelets, there is no corresponding processor, so you need to lock it down. Okay, so in summary, these are my recommendations: is to use rich types as much as possible, meaning not strings. Provide positive input validation. Make sure that you escape all your output properly by using the standard H output text. You should consider using that listener to check for unvalidated components, make it easy. And then finally use that force browsing CSRF thing. And the reason I don't like JSP, part of it is the danger of scriptlets, and we were well uncomfortable in our shop with developers writing scriptlets in the middle of view templates. Facelets offers a lot. So thank you very much. Appreciate your attention today. I hope it's been helpful. And if you have any questions, since we're out of time, I'll let you go to break. Just please come on up and ask me.
You have 5 minutes.